Welcome to Summarize Science, where we break down complex research for everyone to understand. Today, we are exploring a paper that introduces a new way for AI models to think called EndoCoT. Most current image-generating models are great at making pretty pictures, but they often fail at tasks requiring logic. If you ask a typical AI to solve a maze or a Sudoku puzzle, it usually makes mistakes because it tries to finish the whole thing in one shot. The researchers identified that these models lack a chain of thought, which is a step-by-step reasoning process. To fix this, they created a system where the AI iteratively refines its thoughts before it even starts the final image generation. In this diagram, you can see how standard models fail when puzzles get bigger or the font changes, but EndoCoT adapts perfectly. This shows that the AI is actually learning the underlying rules of the task rather than just memorizing patterns. A major problem with older models is that they commit to a final solution too early in the process. By adding a latent reasoning chain, the researchers allowed the model to explore different paths internally. This prevents the model from hitting dead ends in its logic during the creation process. The analysis shows that previous models were essentially performing fragile pattern matching rather than true problem-solving. This framework uses two main parts, one to guide the thinking process and another to make sure the thoughts stay grounded in the original instructions. The training involves a clever two-stage strategy to build up this reasoning muscle. First, the model learns to handle the intermediate steps of a problem, like planning the next turn in a maze. Later, it focuses on making sure the final output looks clean and professional. On page 8, we can see the results of this work in action across 4 very different types of logic puzzles. Whether it is navigating a complex maze or planning a delivery route, the AI solves them incrementally. This step-by-step approach is much closer to how a human would solve a puzzle by hand. The researchers found that their method achieves an average accuracy of over 92% across these difficult benchmarks. This is a significant jump of 8.3 percentage points over the previous best-performing systems. Even as tasks become more complex, such as larger mazes, the model maintains high accuracy. One of the most interesting findings is that the AI's performance scales up as you give it more time to think. By increasing the number of internal reasoning steps, the model can solve much more complex problems without needing more data. This discovery highlights a robust scaling law for logical reasoning in these types of models. The technology isn't just for puzzles, it also makes image editing much more reliable. You can see examples of a scene being built up one step at a time, like adding a stone lantern and then a deer to a painting. This allows for much finer control over how an AI modifies an image based on your instructions. To recap, the researchers have found a way to give brains to the models that usually only focus on beauty. They solved the issue of models guessing too early by forcing them to think through the steps first. This means future AI could be much more reliable assistants for complex planning and spatial tasks. We might soon see image editors that can follow highly complex, multi-stage instructions with perfect logic. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.